Welcome to the quiet cosmos, where we slow down time, soften the noise, and gaze upward into stories written in the stars. Tonight, we begin with a promise that if you close your eyes and listen, you'll learn not just how to see a meteor shower, but how to feel it. This is the story of the 2025 Perseids meteor shower. A falling sky, a comet's dusty memory, and your chance to witness the Earth brushing through a ghost trail of stardust once every year in August. Most nights, the sky does nothing. It sits there, silent, untouched. A black canvas scattered with stars that seem far too still, too eternal to ever move. But once a year around the warm breath of August, the sky begins to crack open. Tiny streaks of light tear across the darkness, like whispers of something ancient breaking through. And while they're called shooting stars, they're not stars at all. They're memories of fragments of a comet that died before we were born. A meteor shower is a beautiful lie. What looks like stars falling are actually dust particles the size of sand grains. They enter Earth's atmosphere at 130,000 miles per hour, burning up from friction, leaving behind brief glowing trails called meteors. But the magic lies not in their size, but in their timing, their return. Every August, we pass through the same cloud of debris like clockwork, like a seasonal memory. Like Earth is retracing its steps through a dream it keeps dreaming every year. And that cloud came from Comet Swift-Tuttle, a 26-kilometer-wide icy body, long gone, but still whispering. Its trail is our destination. Imagine Earth not as still, but as a fast-moving, spinning traveler hurtling through space along its orbital path. Now imagine a road made of dust, a trail left behind by a cosmic wanderer. Each August, Earth drifts into that dusty stream. Not by accident, not by fate, but physics is beautifully reliable, almost poetic physics. This intersection is where the Perseids meteor shower is born. And it's not random, it's cyclical. The Perseids visit Earth between July 17th and August 24th, but peak around August 11th to 13th, when the trail is densest. It's not the meteors that fall toward us. It's we who collide into them. Like a planet longing to touch a memory of something older than us, each meteor you see lasts just a fraction of a second. And yet, in that blink, that glowing arc across the stars, you're watching a 1,000-year-old fragment fulfill its final journey. It was once part of a comet that swept near the sun. The heat caused ice to sublimate, releasing gas and debris, a trail of dust scattered through space. Now, Earth meets that trail, and the dust falls in, burns up, and dies in light. All for you to look up and say, "Did you see that?" And someone beside you may say, "No, I missed it." That's what makes it beautiful. It's gone as soon as you see it. But it's real, like a thought, a breath, a wish. There is something sacred about lying on your back and watching the sky, not through a telescope, not on a screen, but with your eyes, with your breathing, with your silence. You don't chase meteor showers, you wait for them. You lie in patience and in stillness, because nature doesn't perform for noise. It performs for those who sit long enough and wonder. People bring blankets, thermoses of tea. Lovers, children, questions. Some bring grief, some bring hope, and some bring nothing, except the desire to remember what it feels like to just be. The Perseids are not just science. They are a human ritual. Long before we had watches or apps, the night sky was our calendar. Meteor showers like the Perseids marked time for farmers, for philosophers, for priests. Some believed the heavens were weeping. Others saw them as omens, signs from the gods. But even now, in 2025, under satellites and skyscrapers, we still look up, because some part of us never stopped reading the stars. The Perseids remind us that some clocks don't tick. They streak. They've been streaking for thousands of years, even before we had eyes to see them. Many who watch meteor showers alone at night describe it not as an event, but as a feeling. It's quiet. Sometimes it's cold and slow. Very slow. You might wait 20 minutes before seeing even one. But in that time, you're not just watching the sky. You're breathing. You're reflecting. You're remembering something you can't quite name. Because the Perseids don't just fall across the sky. They fall through you. Science tells us that night skies trigger theta brainwaves. The same ones involved in deep relaxation, creative insight, and even early dream states. Watching meteors stimulates all gratitude and feelings of connection to the cosmos. It's not just poetic, it's neurological. You're literally being rewired to feel calm, small, and safe, as if the universe is tucking you in. No wonder so many people fall asleep watching the stars. No wonder channels like this exist to bring the calm of the cosmos back to your mind. So here we are on the edge of August, waiting for the sky to begin. In Section 2, we'll slow things down even more and ask, what exactly are meteor showers? Where do they come from? What is Swift-Tuttle, the mother of this cosmic storm? But before that, lie back, let your breathing slow, and imagine this. A piece of dust, older than human civilization, burning up in the atmosphere just so you can feel wonder. Tonight, we continue our journey through one of the sky's oldest rituals, the Perseids. But before we count falling stars, we need to understand, what are they really? Because it turns out a meteor shower isn't a storm, it's a memory, a returning dream. A soft collision between Earth and something it forgot it was circling through. Before they light the sky, they're invisible. Wandering fragments, ancient debris. Let's define them gently. A meteoroid is a small rock or metal chunk floating through space, often no larger than a pebble, but ancient. Leftovers from the formation of our solar system? Like crumbs from the creation of planets? When a meteoroid enters Earth's atmosphere, it burns up due to friction. That glowing streak you see, that's a meteor. And if a piece survives the fall and reaches the ground, so what we call a shooting star is none of these things. It's not a star, it's not shooting. It's a burning pebble, flaring out in a final goodbye, 60 miles above your head. And most never touch the ground. They die in light. Most meteoroids aren't rogue. They come from parent bodies, comets, or asteroids. Some are chipped off during collisions in the asteroid belt. Others are shed by comets, those icy wanderers that leave trails of dust behind them, like fingers brushing the fabric of space. The Perseids. They come from a comet specifically, Swift-Tuttle. Every time that comet orbits the sun, it loses a little more of its self-shedding particles, like whispers. Those particles remain suspended in orbit, forming a long, delicate trail of invisible dust. And Earth. Faithful, spinning Earth passes through that trail once every year. Imagine walking through falling cherry blossoms. They aren't coming for you. You are walking into them. Now imagine Earth doing the same, moving through a dusty trail left by a long-departed comet. Each particle it hits burns in the upper atmosphere, briefly lighting up as a meteor. That's a meteor shower, not a sky that falls, but a planet that remembers where it's been. The beauty lies in predictability. Earth hits the same part of the trail every year, like arriving at a familiar page in a very old book. You've ever watched a meteor shower? You'll notice something odd. The meteors seem to radiate from a single point in the sky. This point is called the radiant. For the Perseids, the radiant lies in the constellation Perseus, which is why the shower is named as such. Why does this happen? It's all perspective. Just like train tracks appear to meet at the horizon, meteors from a single stream appear to fan outward from one point. They're actually moving parallel, but our vantage point turns parallel lines into a burst of light from a single starry origin. And so the constellation Perseus becomes the gate, not because it causes the meteors, but because that's where they seem to come from. A visual illusion, a cosmic stage trick. But beautiful. Speed is part of the magic. The Perseids travel at 59 kilometers per second. That's over 130,000 miles per hour. It's faster than bullets. Faster than Earth's rotation. Faster than your eye can track. And yet they don't make a sound. No boom, no scream. Just light a silent flash across the blackness. They arrive. They burn. They vanish. It's the ultimate expression of impermanence. 1,000-year-old rock dies in a single heartbeat and we stare, hoping to catch one before it disappears. It's not the rock that glows, it's the air around it. As the meteoroid hurtles into our atmosphere, it compresses the air in front of it. That air heats up sometimes to 3,000 degrees Fahrenheit and becomes plasma. This plasma emits the light. We see a glowing trail that lingers for a second or two before fading. So technically you're not watching the object itself, but the air's response to its arrival. It's like watching a secret revealed, not in the speaker's words, but in the listener's tears. Not all meteors are the same. Some are fast and bright, faint and quick, slow and long-tailed. and some are fireballs meteors brighter than Venus, often leaving trails that glow for minutes. There's even something called a persistent train, a glowing cloud left behind as the meteor's trail ionizes the atmosphere. These rare ones seem to hang in the air, twisting slowly, like a ghost deciding whether or not to fade. Each meteor is different, a snowflake of flame. Some scientists believe that meteorites brought organic molecules to early Earth like amino acids, the building blocks of life. Falling space rocks may have planted the seeds of biology itself. So when you watch a meteor, you might be watching a distant relative of the molecules inside your body. Imagine that, a creature made of cells, watching the ashes of the rocks that helped make you. It's not just astronomy, it's ancestry. Meteor showers don't fall on one city, or country, or hemisphere. They rain across the whole night side of Earth wherever darkness allows. That's what makes them egalitarian wonders. You don't need a telescope. You don't need a mountaintop. It's just a dark sky in time. It's from the deserts of Morocco to the plains of Montana. From Himalayan valleys to Karachi rooftops, people are watching the same falling lights. It's one of the few astronomical events that doesn't require equipment, just your presence. You don't chase it, you let it arrive. Why do meteor showers affect us so deeply? Is it a rarity? The beauty? The idea that something ancient and random is arriving just for us? Perhaps it's because meteor showers remind us that the universe is in motion. Those things fall. Those things return. And that even in a cosmos full of cold mathematical laws, there are moments of gentle spectacle, brief silent ballets of light and fire. In that fleeting glow, we feel small, and somehow more human. They arrive like clockwork every August. But why? What ancient clock ticks behind the veil of stars, sending these streaks of light across our skies, year after year? To understand the Perseids, we must follow a trail. Not on Earth, but far out in the solar system, a dusty, ancient trail left behind by something much older than any city or civilization on Earth. That something is a comet. The Perseids are born from the long, icy breath of Comet 109P, Swift-Tuttle, a giant relic drifting in its elongated orbit around the Sun. First discovered in 1862 by astronomers Lewis Swift and Horace Tuttle, this comet completes its journey around the Sun once every 133 years. It's massive, with a nucleus roughly 26 kilometers wide, nearly twice the size of the asteroid believed to have wiped out the dinosaurs. Yet it doesn't need to collide with Earth to leave an impact. As it loops around the Sun, it sheds tiny fragments of ice, dust, and rock flaking off like the skin of time itself. These fragments remain suspended in orbit, tracing the path Swift-Tuttle once took, forming an invisible river of cosmic debris. Each year, Earth sails through this stream, a silent ship passing through the wake of the comet's voyage. The meteors you see in those brilliant, fleeting streaks of light are not massive space rocks or fiery asteroids. They're mostly no larger than a grain of sand. Some, perhaps, the size of a pea. But when they enter Earth's atmosphere, they're traveling at incredible speeds, up to 133,000 miles per hour. That's over 60 kilometers per second. At that velocity, even a particle smaller than a fingernail slams into the upper atmosphere with explosive energy, igniting a fiery trail that we witness as a meteor. And just like that, dust becomes fire. The forgotten remnants of an ancient comet become a wish whispered into the night sky. It's all about timing and orbital precision. Earth's path around the Sun intersects Swift-Tuttle's debris trail at the same point every year, typically between July 17th and August 24th, but the densest part of the stream, the richest portion, where the most particles cluster, is encountered around August 11th to 13th. This is why the Perseids peak every August. It's a cosmic rendezvous, predictable, intimate, eternal. As you gaze into the sky and watch the Perseids, you'll notice something remarkable. They seem to radiate from a single point, a celestial origin near the constellation Perseus. This is why they're named Perseids. But why do they appear to come from one place? It's an optical illusion, the same way raindrops falling straight down seem to stream outward when you read driving through a storm. From Earth's point of view, the meteors appear to fan out from a single radiant point, located in Perseus, which rises in the northeast sky after midnight. It's not that the meteors are actually emerging from Perseus. They are coming parallel to one another along the same path. But perspective turns a cosmic highway into a radiant starburst. There's a quiet tension in this story, too. Comet Swift-Tuttle, though a bringer of beauty, also holds the potential for catastrophe. Because of its size and orbital path, astronomers have carefully tracked it for centuries. In fact, in the distant future, in the year 4479, there is a potential for Earth to have a near encounter. But that's nearly 2,500 years away. And for now, it simply leaves behind a trail of wonder. Every August, we are reminded not just of its presence, but of how something ancient and distant can touch our skies so delicately and yet so powerfully. But before we move on, let's pause here. Close your eyes and imagine that stream of comet dust gently brushing across the upper layers of Earth's atmosphere. Each streak is a tiny story, each flare a spark from another world, and you watching it all unfold. Under the same sky that has witnessed the fall of empires, the rise of stars, and the passing of comets, you, too, are part of the cosmic rhythm. Each meteor glows for only a second, sometimes two. Then it's gone. But in that second, you see something older than mountains. You witness the memory of a comet, a piece of ice that left home long ago and now returns, once a year in a rain of silent fire. You may see a meteor on any night of the year. Random ones. Sporadic, but meteor showers are different. They are predictable. They come from a specific stream of particles in space. And because of this, they are regular, seasonal, rhythmic, like the tides, like breathing. There are many meteor showers throughout the year. But none are quite as famous as the Perseids. There is something deeply human about watching meteors. They ask for nothing. They offer no sound. They give no warning. But for a moment, they demand your gaze. And in return, they remind you, the cosmos is not just out there. It is happening now, above your head, right now. The same dust you see burning above you tonight has been burning above Earth for thousands of years. Your ancestors saw it. So did theirs. And theirs. Before cities. Before history. Before names. When we look at the Perseids, we're not just looking at falling space dust. We're watching the memory of a comet. We're seeing the residue of creation igniting in the sky. For a brief, breathtaking moment, each spark a signature, each trail a message. You are part of something vast. You are orbiting through a cosmic current of ancient light. And this is the fire that falls every August. We orbit not in solitude, but in a vast celestial web of memory, far beyond the light of our cities and the hush of modern sleep. The Earth spins through ancient debris. Dust not from this world, but from a dying comet Swift-Tuttle, a ghost of ice and stone that passed by centuries ago, whispering trails of itself into the black. Every August, Earth returns, like clockwork, like pilgrimage. It moves into the stream, a hidden trail left behind by the comet's countless visits, looping the sun with a stubborn elegance. This trail is not a wide river of visible stars, but a cloud of particles grains no larger than a grain of sand, some even smaller, floating in orbit for centuries, waiting. The Perseids are born in that collision. As Earth dives into this cloud, at 107,000 kilometers per hour, those particles slam into our upper atmosphere. And though they are tiny, tinier than a fingernail, lighter than ash, their speed transforms them. Friction with the air ignites them in a flash, streak, a spark that lasts a second, but carries the age of the cosmos. These are not just falling stars, they are time striking the atmosphere, history ablaze, a comet's echo, burning. Imagine looking at a silent road, one that stretches invisibly through space. Curving gently around the sun, that road is the comet's path. Every time Swift-Tuttle passed in 1862, in 1992, and even earlier, seen by telescopes, it laid down layers of dust like tracks in snow. These layers drift along the same path, forming a wide ribbon that the Earth intersects at nearly the same date every year. This is why the Perseids return. It's not because the meteor shower begins again, but because Earth returns to it. We are the travelers. The encounter is scheduled not by a single spark, but by orbital mechanics, precise and divine. The angle of Earth's orbit, the lean of our axis, the density of the stream, they all determine how many meteors we will see and how bright they will shine. Some years Earth meets thicker clusters regions, in the stream denser with cometary. Dust in the sky dances with hundreds of meteors per hour. In others, we skim the edge. And the show is more subtle, like a soft whisper of light across the dark. It's a matter of geometry and the illusion of perspective. Stand on a train track and look straight down the rails. In the distance, they seem to converge. Not because they actually do, but because your position gives you only one line of sight. The same happens with meteors. As Earth plows through the comet's trail, all those tiny particles appear to streak outward from one single point in the sky, the radiant in August. That radiant lies in the constellation Perseus, just below the W-shaped Cassiopeia and not far from Andromeda. That's why we call them the Perseids. But the meteors aren't born in Perseus. They're born in Earth's sky as fire from space. Still, the name helps us find them. On a good night, the Perseid radiant rises in the northeast after midnight, climbs high into the early morning sky, and watches over the celestial performance. Look toward it, and you'll see the shorter, brighter meteors. Look away, and longer trails streak overhead like ghostly arrows. Both are born from the same cosmic river. Speed is the artist here. Each particle enters the Earth's atmosphere at around 59 kilometers per second. That's nearly 212,000 kilometers per h. At that velocity, even a fragment the size of a pebble becomes a shooting star. A grain of sand glows white-hot, etching a path of plasma across the night. That glow is not the rock itself, but the air around it heated by friction, ionized into fire. Some leave short, sharp flashes. Others, called fireballs, are larger and brighter than Venus, painting the sky with long, glowing trails. These may even break into pieces, crackling or glowing green or red from trace elements like iron or magnesium. No two meteors are alike. Each one is a signature of its composition, angle, speed, and size. Some flare and vanish like a heartbeat. Some linger with smoky trails that twist like cosmic incense in the wind. All are reminders that even the smallest things, given speed and the right moment, can light up the universe. Why does this happen every year? Because Earth is predictable, and so is Swift-Tuttle's trail. The Earth completes one orbit around the Sun every 365.25 days, which means it crosses the same point in space at roughly the same time each year. And because the comet's dust trail is in a stable orbit, the two meet again and again, but not forever. Over centuries, positions of planets, especially massive Jupiter, can shift the trail. Earth's orbit can wobble, and gravitational resonance can reshape the dance. Sometimes, these shifts mean we get outbursts of intense Perseid showers with over 200 meteors per hour, like in 1993. Other times we get quieter nights, where patience is rewarded with subtle glimmers. 22.5 is expected to be strong. The moon will be a waning crescent dark skies. The stream is thick. The viewing window is wide. The cosmos has planned this meeting with care. Hold a speck of ash between your fingers. It is soft, fleeting, almost meaningless. Yet those same specks in the silence of space become fire when they meet Earth's sky. It's a transformation that only happens at the threshold, at the moment of contact. And it mirrors something deeply human. We carry the dust of old stories, quiet and invisible. But in the right moment under pressure, with enough speed, with a little friction, we light up. We are meteors in our own way. Born of ancient motion, set on paths we do not fully see, igniting only when we touch something vast. We watch them streak across the sky, flaming trails of light born from cold, ancient stone. But have you ever wondered what really happens when a meteor enters Earth's atmosphere? Most of them, especially during a meteor shower like the Perseids, never reach the ground. They burn up, disintegrate, dissolve into particles so fine they become part of the air we breathe. Yet somehow they still touch us, not with their fragments, but with their presence, their light, their motion, their energy. Let's follow that. Journey from cosmic wanderer to fleeting flame and discover how meteors can change our world without ever setting foot upon it. A meteor enters Earth's atmosphere at speeds often exceeding 133,000 miles per hour. That's more than 60 kilometers per second. That kind of velocity slams into the atmosphere with unimaginable force. And though we think of air as nothing, to a speeding meteor, it's like crashing into a wall of invisible fire. Friction compresses the air in front of the rock, heating it rapidly to thousands of degrees Celsius. Hotter than the surface of the sun, the outer layers of the meteor begin to vaporize, glowing with incandescence. That's the moment we see. A shooting star, not because the rock is burning, but because the air is glowing around it. And in that brief moment, it has already begun to die. 90-9% of all meteors you see during the Perseids will never hit the ground. They'll break up miles above the surface, their bodies dissolving entirely in the upper atmosphere. And yet the particles that remain micrometeorites are everywhere. They float down silently. On rooftops, in oceans, in forests, even in your hair. We're constantly being dusted by spacefall, a rain of ancient interstellar matter. You might be walking around right now with the ashes of a comet on your coat. Meteors don't need to crash into the earth to affect us. They move us with their beauty, stir us with their speed, pierce our silence with their light. They teach us something powerful about impermanence, about how a single moment can burn so brightly that it leaves a memory etched forever in our minds, like a whispered message from the universe that says, "You were here, and you were seen," that glowing line across the sky. It touched your eyes, and perhaps something deeper, but not all meteors vanish. A rare few survive the burning descent and fall to Earth as meteorites, silent relics from space. Scientists have discovered amino acids in some of these rocks, the building blocks of life. Could it be that life on Earth was seeded by meteorites? That somewhere in the dark silence of space, a rock carried the ingredients for consciousness across unimaginable distances just to fall, unnoticed, into a puddle and begin everything? Every year during the Perseids, we are reminded that the sky is not empty. It is full of motion, full of memories, full of stories written in flame and silence. When you watch the meteors this August, don't just look up. Feel the weightlessness of a rock that never lands. Feel the heat of a star that never lived. Feel the echo of something that burned. Just once, but left a mark forever. Because in that blink of light, you were touched by a traveler from the stars, and you didn't even need to catch it. Why do we watch the skies? What stirs within us when meteors streak through the heavens? Is it the light, the movement, or something older, something buried in our bones? Long before we had telescopes, satellites, or streaming apps counting shooting stars for us, we had only our eyes. And wonder, in the silence of ancient nights, our ancestors looked up from firesides and fields and saw the sky not as separate from them, but as something alive, something sacred. The Perseids were not just meteor showers. They were omens, messages, signals from gods and spirits, reminders that the universe was still moving, still speaking. In some cultures, a shooting star was a soul on its journey. In others, it was a sign to make a wish, to believe, if only for a second, that the universe could bend itself to your longing, and in all of us. Even now, in the age of apps and algorithms, there remains that old feeling, a hush, a hope, because meteors don't just pass through the atmosphere, they pass through us. They ignite the quiet places within us that still believe in beauty for beauty's sake. They remind us that we are watchers, but also participants in a story written across light years. When we watch the Perseids fall, we are not just observing a cosmic event. We're stepping into a river that's flowed for millennia, a shared human experience. A tradition not written in books, but in stardust and open skies. We lie on rooftops and mountainsides. We whisper to friends and lovers, "There, did you see that one?" We count, we wait, we lose track of time, and in those moments, we are closer to the universe than we are to our phones, closer to the eternal than to our clocks. Maybe that's why we come back. Year after year, not just to see fire in the sky, but to feel it flicker in ourselves, to remember that we too are made of stars. The night sky has always been a mirror for the human soul. Long before telescopes, star maps, and scientific explanations, we looked up and gave names to the glittering trails across the heavens. Meteors weren't just rocks falling through the atmosphere. They were signs, omens, messengers, and miracles, and among them, Perseids held a special place. There's a story told in many cultures. If you make a wish on a falling star, it will come true. But why? The origin of this belief is hard to trace. Yet deeply embedded in the human psyche, perhaps it's because meteors are rare and sudden. They appear like magic just for a moment and then disappear. A brief chance, a fleeting hope. Much like the wishes we carry in silence. To our ancestors, the sky was divine, and anything that broke its calm silence must surely carry meaning. A falling star was a message from the gods, or a window into the other world. A moment when the heavens opened, if only for a heartbeat. The Perseids, with their frequent bright flashes, gave us many such moments. So even today, when science has explained the dust of comet Swift-Tuttle and the mechanics of Earth's orbit, we still lie back, eyes wide, and whisper secret wishes to the stars. In some parts of Europe, especially in Catholic tradition, the Perseids are known as the Tears of St. Lawrence. The peak of the meteor shower often falls near August 10th, the feast day of St. Lawrence. A Christian martyr who was said to have died in 258 AD, legend has it that the sky weeps fiery tears in his memory. The stars themselves, it was believed, mourn his sacrifice. It's poetic. Pain and beauty falling together from the sky, this blend of myth and astronomy shaped how people viewed the cosmos. Even as science advanced, the stories remained. They gave emotional weight to the observations. They turned data into dreams. In ancient Japan, meteors were believed to be the spirits of ancestors traveling between the worlds. In Polynesian cultures, they were fiery canoes crossing the celestial ocean. In Greece and Rome, they were omens, sometimes good, often foreboding. Each culture, each tribe, wrapped its fears and hopes into the streak of a meteor. We didn't just watch them, we listened. We asked, what does it mean? Even now, when a particularly bright fireball flashes across the August sky, it feels like more than just science. It feels like a message, a reminder, that we are small, that time is short, and that something greater, something unknowable, watches over it all. The magic of meteor showers doesn't come from what we see. It comes from what we feel. It's the hush of the world when the night is quiet, the gasp when a meteor burns bright across the sky, the laughter of friends watching together on a dark hilltop, the solitude of a lone observer beneath the stars, the memory of someone you once watched the sky with, the feeling that maybe the universe is listening. And this is the deeper truth of the Perseids. They connect us. Across time, across space, across cultures. They connect past to present, science to the soul, myth to meaning. We watch them now with apps, telescopes, and high-definition cameras. But we also watch them with hearts that still wonder, hope still, wish. The Perseids aren't just about particles from a comet. They're about what it means to be human, to look up, to believe in something bigger than ourselves. As we prepare to gaze upward into the vastness, to the cascade of ancient dust and icy whispers, it's important to remain grounded, to know not only when to look or where, but how. Not just scientifically, but kindly, carefully, respectfully. The sky offers itself freely. But the earth, your temporary platform to witness this celestial ballet, also has rules. Not laws, perhaps, but quiet etiquettes. Stargazer to stargazer. Human to night. Soul to silence. Let's begin with safety. It's the kind that keeps your experience warm and worry-free. The Perseids reward those who leave behind artificial light. That means seeking out remote places far from city glare, beyond suburban haze. But darkness, too, hides its challenges. Bring a red light flashlight, not the blinding white kind. Red light preserves your night vision, allowing your eyes to adapt to the dark while still helping you navigate your surroundings. It's a simple tool, yet a powerful one. It's connecting you to the rhythm of the wild night. And yes, pack a blanket, extra layers, even in August. High altitudes and open skies can become surprisingly cold. The stars are eternal, but our human bodies still shiver. If you're heading to the countryside, a quiet desert, a hilltop, or a national park, know your terrain. Scout the area in daylight if possible. Avoid cliff edges, unstable rocks, or wandering off established paths. Bring a friend if you can. Stargazing is beautiful in silence, but safety often comes in pairs. Check local wildlife warnings, particularly if you're in bear country or desert regions. The stars will still be there tomorrow, but a misstep in unfamiliar land could cost you more than a missed meteor. And don't forget cell phone signals, may be weak or non-existent in remote locations. Download offline maps. Let someone know where you'll be now. For etiquette, that unspoken harmony among strangers beneath the same sky. If you're sharing your stargazing spot with others, keep voices low. The quiet is part of the experience. The Perseids don't need narration. Speak for themselves in fire and flight. No loud music, lest you're alone and the night has consented. Avoid turning on bright lights or phone screens. That single second of brightness can erase someone else's 30-minute dark vision. If you're using a telescope or binoculars, share them generously. The night is generous too. Remember, under the stars, you are part of a temporary, ancient community. One of the oldest gatherings in human history, people looking up together. In wonder, the Perseids may be a cosmic gift, but you're stargazing. Sight is part of Earth's fragile skin. Take nothing, leave nothing, no wrappers, no bottles, no cigarette butts. The stars give freely, but the ground should look the same after you leave as it did when you arrived. If you're in a national park, follow leave no trace principles. If you're in a private area, seek permission before entering. If you're near wildlife, respect its rhythms, its silence, its space, and perhaps before you leave, take a moment to say thank you. To the land, to the sky, and to the ancient dust that chose to fall tonight. Stargazing isn't just about what your eyes see. It's about what your body feels and what your soul hears. You may notice the soft call of an owl in the distance. Wind rustled the trees, near silence between two falling meteors. These moments are gifts in a world that moves too fast. This night, this single August evening, is a rare invitation to simply be, to lie still, to breathe, to witness, and so. As you watch the Perseids dance their ancient dance, may you also feel your own smallness, not as insignificance, but as belonging. You are part of the cosmos now, just one more watcher, one more soul beneath the sky. This is how we watch the sky, not just with open eyes, but with open hearts, not just with science, but with reverence. The Perseids do not demand worship, only presence, and perhaps on this warm August night, that's enough. As the last streaks of light vanish into the early morning mist, the Perseids begin to fade. One by one, the meteors burn out, not in a grand finale, but with a slow hush, like the embers of a fire losing their last breath. The great cosmic theater closes its curtain not with noise, but with stillness. And just like that, the skies return to silence. But something is different. Not in the heavens, but in you. You've stood beneath a moving sky. You've tilted your head toward infinity. You've felt the sheer scale of space and the humble beauty of dust dancing through our atmosphere. That is the real miracle, not just the meteors themselves, but the human act of watching. For a few nights each year, millions across the globe look up together, unknowingly synchronized in wonder. From deserts to dense cities, mountaintops to ocean shores, we gather in silence, bound by the shared act of looking upward. It's one of the few remaining rituals in the modern world that needs no temple, no priest, no technology, only time and patience. And then it ends. The Perseids leave. No trace behind, at least not physically. But emotionally, psychologically, and perhaps even spiritually, they etch something permanent into us. A reminder that beauty doesn't always announce itself with fanfare. Sometimes it arrives quietly burning, just long enough to be remembered. So, as you walk back inside, or return to your campsite, or drive home beneath the soft glow of headlights, pause, reflect, replay the streaks in your mind like echoes, and know that this too was a gift, a moment between you and the cosmos. It's unfiltered and alive. And remember this, the Perseids will return. They always do. Like a heartbeat in the sky. Their rhythm is older than history, predictable yet magical, scientific. Yet sacred, you don't need to chase them. Just be ready, because the sky doesn't ask us to control it. It's only to witness it. To be still, to be quiet, to look upand, to remember that we, too, are stardust. Watching stardust, until next August, sleep. While under the quiet cosmos,